Welcome to Smart Classes. Today our topic is refraction of light. Now the whole idea behind the refraction of light is that when light goes from one medium to another medium, it deviates from its original path. That is, जब light एक medium से दूसरे medium में enter होती है, so it deviates from its original path. So here's the interface. This is the interface. By interface we mean the surface that separates the two transparent medium. And here is medium 1. So this is medium 1 and this is medium 2. And this is the interface, the surface, the boundary जो मीडियम फर्स्ट और मीडियम सेकंड को सेपरेट कर रही है, ठीक है. एंड लेट द रिफ्रैक्टिव इंडेक्स ऑफ द मीडियम 1 इज mu1. This is refractive index of medium 1, and mu2 is refractive index of medium 2. Now, let the light is initially traveling in medium 1. So this is the light initially traveling in medium first or medium 1, and a line that's normal perpendicular to the interface at the point of incidence is called a normal. So this line is normal. Normal वो line होती है जो perpendicular होती है to the interface at the point of incidence, and we call this angle of incidence, that is the angle incident ray makes with the normal. Incident ray का angle normal के साथ है, we call this angle of incidence. And ये जो ray of light है ये initially medium 1 में है, now it goes into medium 2, it goes into medium 2, and according to the refraction of light, when light goes from medium 1 to medium 2, it changes direction. So you can see that there is a change in the direction of light as it goes from medium first to medium second. And this change in the direction of light is called refraction of light. I'll repeat, refraction of light. It's the phenomenon of change in the direction of light when it goes from medium 1 to medium 2. And this angle we call angle of refraction, that is the angle refracted ray makes with the normal, ठीक है. And this angle incident ray makes with the normal is called angle of incidence. So this is called incident ray. This is called incident ray, and this is refracted ray. This is refracted ray. And refraction of light, it follows some rules. It follows some laws. And let's now discuss laws of refraction or rules of refraction. Rules or laws of refraction. Now the rule first is incident ray, refracted ray and normal. They all lie in the same plane, and here they lie in the plane of the board. So I repeat, I'll write that incident ray, refracted ray and normal, and all lie in same plane. All lie in same plane. So this is rule first. Incident ray, refracted ray and normal, they lie in the same plane. And rule second is Snell's law. Snell discovered that the sine of angle of incidence to the sine of angle of refraction. So Snell discovered that sine of angle of incidence divided by sine of angle of refraction, and the ratio of the two is always constant. The ratio of the two is always constant, and this constant we name as mu2 with respect to 1. That sine of angle of incidence divided by the sine of angle of refraction is equal to refractive index of medium 2 with respect to the medium first. So I write the constant the constant mu21 is refractive index of medium 2 with respect to medium first, with respect to the medium 1. Now medium first is in which instant ray is traveling, and medium second in which refracted ray or refracted light is traveling. Now, so this mu2 refractive index of medium second with respect to medium first, we can write it as mu2 refractive index of medium second with respect to medium first is mu2 by mu1. So if we call this equation first, now equation first becomes sine of angle of incidence divided by sine of angle of refraction is mu2 divided by mu1. So mu2 is the refractive index of the medium in which refracted ray is traveling, and mu1 is the refractive index of the medium in which incident ray is traveling. So this equation can be written as sine mu1 goes here, so it's mu1 sine I divided by mu2 sine R. So this is also Snell's law. And now we will use this law to explain why light, when it goes from medium 1 to medium 2, when light goes from medium 1 to medium 2, it deviates from its original path, that's it bends. And this bending of light, when it goes from one medium into another medium, is called refraction of light. Now we will use Snell's law when light will bend towards normal, and when light will bend away from normal, and when light will not bend at all when it goes from medium first to medium second. Let's use Snell's law to answer these questions. Now if mu1 is or mu2 is greater than mu1, if the refractive index of medium 2 is greater than the refractive index of medium first, that means that medium 2 is denser with respect to the medium first. That is, medium 2 is denser with respect to medium first. So according to Snell's law, if mu2 is greater than mu1, then since इन दो टर्म्स का प्रोडक्ट इन दो टर्म्स के बराबर है, अगर mu2 ज्यादा होगा mu1 से, then sin of r must be less than sin I. mu2 is greater than mu1, then sin r must be less than sin I. And sin r कब होगा less than sin I? When r is less than I. That is, so this implies r is less than I. So r is angle of refraction. अगर angle of refraction कम है angle of incidence से, so that means light bends towards normal. तो light जो है ना इसको bend होना पड़ेगा towards normal. When it goes from medium first into medium second, तो since medium second is denser with respect to medium first, and according to Snell's law, अगर mu2 ज़्यादा है mu1 से, then sin r must be less than sin I, and sin r less than sin I meaning r must be less than I. And r कब होगा less than I? When it bends towards normal. And similarly, if mu1 is greater than mu2, अब अगर mu1 ही greater होगा mu2 से, that implies that medium 1 is denser. Medium 1 is denser than medium 2. Now according to Snell's law, अगर mu1 ज़्यादा है mu2 से, then sin I must be then sin r must be greater than sin I, because mu2 जो है ये mu1 से कम है, तो it implies sin R must be greater than sin I, and sin R कब greater होगा sin I से? when R is greater than, when R is greater than I, R greater than I, and R greater than I means जो light है इसको bend होना पड़ेगा away from normal. So point is, if light goes from rarer to denser medium, light bends towards normal because R is less than I. If light goes from denser to rarer, because second case में हम बोल रहे हैं कि mu1 ज्यादा है mu2 से, अगर medium 1 का refractive index greater है medium 2 से, तो इसका मतलब होगा medium first is denser medium and medium second is the rarer medium. Now light is going from denser medium to rarer medium, तो इस केस में जो R है it must be greater than I, and R greater than I means तो जो ray of light है it has to bend away from the normal. So it is Snell's law that explains when light will bend towards normal or away from normal. If it is going from rarer to denser, according to Snell's law, it will bend towards normal. If it goes from denser to rarer, according to Snell's law, it will bend towards the normal. Because when it goes from denser to rarer, it bends away from normal. तभी R जो है ना वो greater होगा I से. And if the light is incident at the interface normally, if the light is incident at the interface normally, and normal incidence के case में this will be the situation, incident ray it is incident at the interface normally, तो इस time angle of incidence होगा 90 degree. So इस ray of light का जो angle of incidence है normal के साथ that is 0 because it comes along normal. Now according to Snell's law, when I is 0, that's this case, ray is incident normally at the interface and ये along normal आ रही है. So I 0, then according to Snell's law, which implies R must be 0. Because mu1 and mu2 cannot be 0. So if I is 0, तो तब R 0 होना पड़ेगा. यानी जो ray of light है, इसके लिए angle of refraction भी 0 होगा. And angle of refraction 0 means it goes undeviated. So this ray of light, it will go undeviated. I 0, I is 0, not 90. So I is here 0 and R is also 0. So this follows from Snell's law. अगर I 0 होगा, then R has to be 0. I कब 0 होगा? जब incident ray along normal आ रही है, तो ये along normal ही refract हो जाएगी, यानी it goes undeviated. And right, this means that if a ray of light is incident at the interface, normally, then it goes undeviated. It follows from Snell's law, if I 0, then R has to be 0. And let's now discuss refractive index. Refractive index denoted by mu. Actually, according to refraction of light, when light goes from one medium into another medium, it deviates, it changes its direction, and this change in the direction of light is called refraction of light. Question is कि light जब एक मीडियम से दूसरे मीडियम एंटर होगी तो लाइट कितना इसकी डायरेक्शन चेंज हो जाएगी, ये कितना डिविएट होगी, ये कितना बेंड करेगी when it goes from one medium to another medium. It depends on the refractive index. And what's the refractive index? How it is defined? It is the ratio of refractive index. It is the ratio of It is the ratio of velocity of light in vacuum. It is the ratio of velocity of light in vacuum to the velocity of light in medium. Now, refractive index is denoted by mu, and velocity of light in vacuum is denoted by c, and velocity of light in a medium is denoted by v. So this is the expression for the refractive index of the medium. It's velocity of light in vacuum divided by the velocity of light in the given medium. And जो velocity होती है light की vacuum में, that is 3 into 10 raised to power 8 meter per second. So this is the velocity of light in vacuum. And we can rearrange this equation as V equal to C divided by mu. And this equation defines the role of refractive index. The greater is the refractive index of the medium, the lesser is the velocity of light in that medium. So medium के लिए जितना refractive index ज़्यादा होगा, उतना उस medium में light की velocity कम होगी. And vice versa. अगर refractive index medium का कम होगा तो उसमें velocity of light ज़्यादा होगी. It's like current. जो current और resistance में relation है, I equal to V by R according to Ohm's law. The greater the resistance of a conductor for a given potential difference, जितना resistance conductor की ज़्यादा होगी, उतना conductor में current कम होती है. So just as resistance is opposite to the flow of current, we can say that refractive index will say it's the opposition to the propagation of light in a medium. और जितना medium के लिए refractive index ज़्यादा होगा, उतनी velocity कम होती है light की उस medium में. And we can calculate knowing the refractive index of a medium. अगर हमें ये medium का refractive index पता होगा तो हम उससे velocity क्या होगी light की उस medium में वो हम निकाल सकते हैं. For example, question is calculate velocity of light in glass. And we know that velocity of light in a medium is speed or velocity of light in vacuum divided by the refractive index of the medium. So अगर हमें calculate करनी होगी velocity of light in glass, so we write Vg, that is velocity of light in glass, velocity of light in vacuum divided by the refractive index of the glass. And the refractive index of the glass mu g is 1.5. It's a pure number, no unit, because it's velocity divided by velocity, meter per second. So units cancel out. So mu is it's a dimensionless quantity, no units. So glass के लिए mu जो है वो 1.5 है. So velocity of light, then the velocity of light in glass is C, which is 3 into 10 raised to power 8 meter per second divided by mu. Glass के लिए 1.5 है, so 3 divided by 1.5, that is 2 into 10 raised to power 8 meter per second. And this is Vg, that's 2 into 10 raised to power 8 meter per second velocity of light in glass, and this is the 70% of the speed of light. This is the 70% of the speed of the light. So light की जो velocity है glass में, it is 70% of c जो इसकी velocity होती है vacuum में. In other words, light loses 30% of its speed when it travels through the glass. जब light glass के through propagate करती है, glass के through travel करती है, it loses 30% of its speed. So knowing the refractive index of the medium, अगर हमें किसी medium का refractive index given होगा, तो हम उस medium में velocity of light calculate कर सकते हैं. Similarly, we can calculate velocity of light in water. So calculate velocity of light in water, and given for water, refractive index mu w is 4 by 3, that's 1.33. Refractive index of water. Now, velocity of light in water will be velocity of light in vacuum divided by the velocity divided by the refractive index of the water. That's mu w. So it's 3 into 10 raised to power 8 meter per second divided by mu, that's 1.33. Or we can write this equation as mu w, velocity of light in water, is equal to 3 divided by 1.3. It will be almost 2.25 into 10 raised to power 8 meter per second. And 2.25 into 10 raised to power 8 meter per second, that's 75% of the speed of light in vacuum. That is, जो velocity है light की water में, it is 75% of the velocity जो इसकी vacuum में है. In other words, light loses 25% of its velocity when it goes through water. So clearly it means कि V और mu में inverse relation है. जितना refractive index medium के लिए ज़्यादा होगा, उतनी उस medium में velocity of light कम होगी, and vice versa. And a medium with smaller value of mu, mu का value जितना कम होगा medium के लिए, we call that rarer medium. And the greater value of mu, refractive index for a given medium, we call that denser medium. That is a medium with smaller value of mu, refractive index. A medium with smaller value of mu, refractive index, is called a rarer medium. So this is the definition of rarer medium. किसको बोलते हैं कि जिस medium का mu का value कम होगा, that medium is called a rarer medium. And similarly, a medium with greater value of mu is called denser medium. So denser medium किसको बोलेंगे? जिस medium के लिए mu का value ज़्यादा होगा, we call that medium as denser medium. So thank you very much.